Hi everyone, how are you? Am I audible? Okay, if I'm audible, just wave your hands. School 1, school 2. Okay, that's great. So I am audible. So let's wait for school 2 to switch on their cameras. Okay, school 1, can you unmute yourself? School 1, can you unmute yourself? Okay, now I believe that I will be able. I am able to hear you clearly. That's great. So school 2, can you just unmute yourself? Okay, that's very good. I can also hear school 2 as well. So everyone, how are you all? All good? Did you enjoy your Sunday holidays? Okay, that's great. So did you revise the things? No. No, okay. How many of you didn't studied on Sundays? Okay, no one. And how many of you studied in Sunday? Like in Sunday, you have just revised the portions, did your homeworks and all? How many of you? No one. No one has studied on Sunday. Okay. So in the last class, there was a student from school 1 whom I asked to sit in the first row middle bench. Is he sitting?
Ganesh.
Ganesh. Is he there? Yes. Call him.
Absent, sir.
Absent. He's absent today.
Sir.
No issues. So let's start the session, everyone. Ready? Okay. Should I start? Or some students are coming? Okay. Okay, that's great. So let's start the session. So today what we are going to do is that, let's see. So we have discussed most of the topics of this chapter. Yes or no? Yes. The chapter is on the verge of completion. So we have discussed the types of substance around us, right? We have discussed types of mixture. We have discussed the solution. Each and every detailed thing about the solution has been discussed. Yes. We have also discussed about the colloidal and its types. Yes or no? The whole table remembered? Yes or no? That's great. And we have also started the separation techniques, right? But we didn't able to complete. So today we are going to complete these all the separation techniques. So techniques. Okay, everyone?
Okay, sir.
Ready? That's great. So let's start. Let us start with the today one question that we discussed in like 2 to 3 classes before. This is a numerical question, right? So I want you to solve this numerical ones. So the question says that a solution contains 40 gram of sugar and 100 gram of water. Calculate the mass percentage of the solute in the solution. And this question should be solved by each and every one of you.
Sir.
Yes?
The screen is not visible, sir.
My screen is not visible?
Yes, sir.
Okay, I will reshare my screen. Just give me 1 second.
Okay, sir.
Sure. Was it not visible from the starting?
Yes, sir.
Okay.
No, sir.
Okay, I'll reshare the screen. Just give me 1 second and you will be able to see my screen. Okay. Is it now visible?
No, sir.
Can you just switch the gallery view like I take it?
Not visible, sir.
Now visible, no? Okay, that's great. So again, school 2, all good? School 2, are you able to see me? Are you able to see my screen? My audio is clear to everyone?
Yes, sir.
That's great. Okay, so let's solve this question. And this question, I need each and everyone. I want each and everyone to solve this question. Okay. So the question says a solution contains 40 gram of sugar and 100 gram of water. Now you have to calculate the mass percentage of the solute in this particular solution. Okay, I'm giving you 2 minutes to solve this question. Be very quick. Be very quick about this question, everyone. Let's see who is going to get the answer first. Yes. 1.4. Yes. I was unable to hear that. Was someone saying something? Okay. Yes, fast. You should not take so much long time to solve this question because we have discussed these types of questions in previous classes also. Yes or no? Fast. Let's see. Okay. Yes. 1.4. Anyone who got the answer? Anyone who got the answer? No one? Yes? 1.4. Okay. Let's solve. Okay, how many of you have solved this? How many of you are trying to solve this? And how many didn't understand that what we have to do in this question? Anyone who completely didn't understand that what we have to do in this question? Anyone, please raise your hand because I'm going to check it personally. Yes, 40 by 100. 40 by 100. 40 by 100. Last time also you all made the same mistake. Think about it. Is it 40 by 100? 100 by 40.
40 by 140.
40 by 120.
40, sir.
1 exactly. 40 by 140 we will be having, right? Why? Because it is talking about the mass percentage and we are talking about the mass of the solution, right? So if you are mixing 40 gram of the sugar with 100 gram of water, right? So what will be the mass of the whole solution?
140.
140, right? So then 40 upon 140 upon 100. Yes or no? How many of you did this thing? How many of you did this thing? School 2? Okay, that's great. Okay, in school 1, how many of you did this thing? No one. Okay, who answered this thing? I can't, maybe you are like not coming in front of the camera. Is there any boys sitting in the left hand side who did this thing? No? Okay. Okay, that's great. So 40 divided by 140 multiplied by 100. We need to solve this and we are going to get the answer. Yes or no? Okay. So let's solve. Then what we are going to get 40 multiplied by 10 upon 14. Now how you are going to solve this? Can we do from 7 or from 2, like 2 sevens are 14 and here we will be having 20. Yes or no? Yes. So then we will be having 20 multiplied by 10 upon 7. Yes or no?
Sir.
And then it will be 200 divided by 7. Can you do this? Who is going to solve 200 divided by 7? Can you do this?
Yes, sir.
Solve it fast. I need to check who is going to get the answer first. Yes, everyone. I'll call the name. Should I call the name for the answer, or you're going to give me the answer by your own? Okay. So I'll wait for the answer. Fast, fast, fast. Okay. Yes, the answers. Yes, yes, yes. Okay, anyone who knows how to solve this question quickly, like it will take less time to solve this calculation. Yes, try it. Instead of doing 200 upon 7, we can also do 20 upon 7, and whatever the answer we get, we'll just multiply it by 10. Yes or no? That can be also done, right? Yes or no? Didn't understand? See, in this, how we can reduce the calculation time? We have 20 into 100, right? Divided by 7. So instead of doing 200 into 7, can we do 20 divided by 7? Yes or no? Let's see. It will be 2. 2 sevens are 14. And how much you are going to lift? It will be 6, right? Then you have to give the point. It will become 0. And can we do 7 eights are 56?
Yes, sir.
And then again we are going to get 4. So this much decimal calculation is okay. We can do this, right? Like we don't need 3 to 4 decimal digits, right? 2.8 is okay. We can stop the calculation here. So 20 divided by 7 multiplied by 10 will be what? It will be 20 divided by 7. We got 2.8 into 10. Will it be equal to 28?
Yes, sir.
Understood what I did?
Yes, sir.
Yes? Clear to everyone?
Yes, sir.
Okay, so I'll write it neatly for you for everyone. I'm going to write this thing in here. So firstly, what we did, we got to know that we have to solve 20 divided by 10 into 7, right? And then we are going to get our answer. So instead of 20 into 10, what we did, we just did 20 upon 7 into 10, right? This can also be done. Yes or no? We can write it like this as well. Yes or no? Can't we do this? Can't we do this? Yes. So it will be what? It will be basically 2.8. And if we multiply it by 10, we are going to get 28%. Yes or no? Yes. Why we did this? Because we have solved this term individually and then this term individually, right? This is applicable for this kind of questions only. Like for every questions, you just can't, just solve it individually and multiply. Clear to everyone?
Yes, sir.
Yes or no? So that's good.
Sir.
So yes. Should I move forward?
Yes, sir.
Okay, that's great. Now see, let us start with the separation techniques, right? So today we are going to discuss all these separation techniques. Yes or no?
Sir.
Everyone ready?
Yes, sir.
That's great. So let's start with the separation method. So see, we know that we have different kinds of solutions. Yes or no? Different kinds of mixture. So we will be focusing on the separating homogeneous, heterogeneous, miscible, immiscible liquids also. Okay,
Yes, sir.
clear? So we know about the homogeneous mixture, right? That's why I have not included homogeneous mixture here. So simply we can write homogeneous mixture means what? Everyone knows about the homogeneous mixture. Yes or no?
Yes, sir.
What is that? What is that? Mixture or solution having the same composition. Yes or no?
Yes, sir.
So I can write here homogeneous mixtures having same composition, right?
Yes, sir.
And what about the heterogeneous mixture? How many of you know about the heterogeneous mixture? Same composition or different composition?
Composition.
Same,
Different.
different composition. Yes. So heterogeneous mixtures or heterogeneous solutions are those kind of solutions which is having what? Which is having different kinds of different composition, right? the composition is not constant. Yes or no?
Sir.
Now, how many of you know about the miscible and immiscible liquids? Yes. Okay, I'll give the example. I'll give the example and try to think that what can be miscible and immiscible liquid. Okay. So the example for miscible liquid can be, let's have milk and water. Okay. This can be one example. Second, the example for immiscible liquids can be water and oil. Any guesses what can be the definition of this miscible and immiscible liquid? I have given you the examples. Think about it. Okay. Do oil and water mixes thoroughly? Can we mix oil and water? No. So the liquids which do not dissolve in each other or which do not mix with each other, those kinds of liquid are known as immiscible liquids. Exactly. These liquids do not dissolve, or we can say, or do not mix with each other. And what about the miscible liquids? Yes, these are those kind of mixtures in which what happens? The liquids mixes or dissolves in each other. Yes or no? That's great. With each other. Now, are you all ready to read the separation techniques of each and every kind of solutions of each and every kind of mixtures? That's great. So let's see. The very first separation method which we are going to discuss will be evaporation. Clear to everyone? Okay. Now, this kind of separation methods can be used to separate homogeneous mixture. What kind of mixture can be separated by evaporation? Homogeneous mixture. One example is given, ink and water. Any example of homogeneous mixture which we can use in this? Any other example of homogeneous mixture? Yes. Any other example? Think about it. It's very easy. Yes. Salt and water. Exactly. We have salt and water. Now let's have a look over the process. So the process we are going to have, we are going to see a video and then we are going to write the process. We are going to write the points of those process. Okay, everyone?
Yes, sir.
Okay, so now everyone has to see the video very clearly, and whatever I'm going to explain, you have to hear it carefully. After that, I'm going to give you 2 minutes time to write it down, and in the between, nobody is going to write. Okay? Clear, everyone?
Yes, sir.
Ready?
Yes, sir.
Okay, that's very good. Okay, just give me 1 second. I'll reshare my screen. Okay. Okay, everyone, we know the process of evaporation. Yes or no?
Yes, sir.
Have you done the evaporation before? Yes or no? That's great. So let's see, let's have a look at what kind of evaporation do we have in this particular video, right? So I hope that you are able to view the screen. Yes or no?
Yes, sir.
That's great. So here what they are doing, we have to check that, right? So we have what? We have this particular video. In this, they are performing the evaporation. So first of all, we don't have to try any kind of reactions at home because they can be dangerous for us. Okay? So all the reactions, if you are going to try, you are going to try with the help of in front of your teachers or in front of a particular elder person. Yes or no?
Sir.
Clear? That's great. So now let's see what we are going to do here. So first of all, we are going to take what? We are going to take a beaker, and in that beaker, we are going to add salt and then the water. Okay? Clear?
Sir.
So we have created a solution. Yes or no? Salt and water solution has been created.
Sir.
Now, what we are going to do, we are going to just heat this mixture. Basically, what we are going to do, we are going to boil this mixture, right? And if we are boiling above 100 degrees Celsius, then what will happen? The water will evaporate or not?
Sir.
Yes. And if we are heating, if we are boiling to the above the 100 degrees Celsius, then water is going to slowly, completely evaporate. Yes or no?
Sir.
And are you able to see the salts left behind it?
Sir.
Yes or no?
Sir.
Clear? Understood the process, how we are going to do the this evaporation process to separate the homogeneous mixture?
Sir.
That's great. Okay, I want everyone to think about it, to note the process what we have discussed, and I'm going to ask some of the students to explain that process to us. Okay, giving you 2 minutes to note down whatever we discussed right now. Quick, come on, quickly, write fast. Everyone. Yes, I'll reshare. I have stopped my screen sharing so that you are going to write it by your own. Write it fast. Otherwise, everyone is going to write. That's why I asked you to listen to me very carefully. Let's see how many of you have listened it carefully. Okay, just 2 minutes. I'm not going to give more time. Let's see who has listened it very carefully. Yes, school 1, school 2, let us see. School 1 and school 2, help me to write all the processes as soon as possible. Everyone, let's see who is going to give me the answer first. No one? Just write the key points, okay? I don't want a very lengthy, process and all those things as statement form. Just write the points. Yes, yes, yes. Should I call some of the students?
Yes, sir.
Okay. Everyone done?
Yes, sir.
That's great then. So let's have, okay, Ganesh is absent, right?
Yes, sir.
Okay, so next let's have from school 1, we can have, let me check. I can see some of the students. Do we have Nirmala? Okay. Why I always call the names of the absentee students? Okay. Now let's have, do we have Rohit?
Absent, sir.
Oh my God. Okay, do we have Varun?
Sir, Rohit is present, sir.
Rohit is present? Okay, call him then. Yes. And from school 2, let's have, okay, from school 2 also, do we have Rohit? In school 2 also, do we have a Rohit? Yes. Okay. From if Rohit is absent from school 2, then let's have Umesh or Uday. Umesh, do we have? School 2? No? Okay. School 2, do we have Uday? Okay. Do we have Lucky? Yes. Okay. So let's hear the answer from the school 1 first. Okay. So what was the first thing we did? Yes. Yes. Other students, don't talk. Please listen to the answer. Yes. Yeah, what we have done, we have taken salt plus water. Yes or no? Yes or no?
Yes, sir.
And then after that, what we did? Yes. Heated the mixture. Yes or no? So let's write here, heated the mixture. After that, what we have got? Did we able to separate the salt and water? Yes or no?
Yes, sir.
Okay, that's great. So let's write here, salt and water. Salt and water was separated. Clear? That's great. Okay. Now, so everyone understood this particular question?
Yes, sir.
This particular concept, everyone understood?
Yes, sir.
That's great. That's great. So now let us, should we go with the another process?
Yes, sir.
Okay. Everyone, yes, you can go back to your place, Rohit. Clap for Rohit for letting us to write this process. Now, once everyone repeat after me. In the evaporation, school 1 and school 2 both. In the evaporation, what we have to do? If we have a homogeneous mixture, we just have to heat it. Yes or no?
Yes, sir.
And after heating, we will be able to separate the solute and the solvent component. Yes or no?
Yes, sir.
That's great. So now, any doubts in this?
No, sir.
Should we move forward? School 1, school 2, both of you?
Yes, sir.
That's great. Now, next we have a method which is called the paper chromatography. Have you heard about this method? Okay. Now see, again, this is also used to separate the homogeneous mixture. Which kind of mixture? Homogeneous mixture. Now, this thing you can also do at your home. What you have to do is that you have to take a piece of paper and you have to use your marker. Now, do you know the permanent marker which we use to do underline and all those things? Yes or no?
Yes, sir.
Okay. So for this, what we are going to do is that we are going to use that particular marker. We are going to use that particular marker and we are going to mark this. We are going to mark that thing in the piece of paper. Okay. Let's suppose we have this piece of paper and here we are going to mark it. Okay. We are going to draw a circle. Yes or no?
Sir.
And let's see after this what we are going to do. Ready, everyone?
Sir.
That's great. So let's see after that what things we are going to do. So again, same thing. I'm going to show you the video and you know what you have to do?
Yes, sir.
You have to listen it carefully, right? And nobody is going to write down. Okay. And after that, we are going to discuss the process. Ready?
Yes, sir.
That's great. So let's have the video here. So I hope that the video is visible to everyone. Yes or no?
Yes, sir.
So let's start with the process called the paper chromatography. So again, why we are doing this? We want to see that what are the components which are present inside a black ink. Okay, like can you see the other inks in the black color? No, we can't, right? But there are presence of the some of the colors in the black ink. So we just want to separate those colors. Okay. So let's see quickly. So first of all, what we have some of the inks present here. We have a distilled water and we are going to take this particular paper. Okay. So can you see this paper?
Yes, sir.
Now we are going to just mark a particular line through which, like above this, we are going to do what? We are going to mark the colors. Okay. So one horizontal line and one vertical line. And this line is of 4 centimeter distance from the tip and that line is of 4 centimeter. Okay. Now see, what we're going to do is that we are going to pick red ink plus blue ink. It's a combination, like black ink is also considered as red and blue ink. So now what we have done, we have just put that ink in a point P. Okay. Instead of this, we can also take the black ink. Why? Because black ink is also what? They are also made up of some of the colors. I can see some of the students writing. Now see, in our test tube, we are going to do what? We are going to put some water. Okay. And there we have a chromatography chamber. We are going to fill that particular water in this chromatography chamber. Okay. And then we are going to do what? We are going to use a chemical which is known as isopropyl. Okay. And that thing also we are going to put in the chamber. Ready? Okay. Yes or no?
Sir.
And now we are going to just mix it. And then we are going to bring back the paper. So let's see. We're just going to put this paper in this chamber and we're going to wait for a while. What will happen? The paper is going to absorb the water, yes or no?
Sir.
Yes. So let's see. When the paper is going to absorb the water, can you see the two different colors?
Sir.
Can you see the two different, as the water is rising, the colors is separated, yes or no?
Sir.
So this is what? This is known as the paper chromatography, yes or no?
Sir.
Clear to everyone?
Sir.
And this is how you are able to separate the components of ink. Now, everyone write the procedure and let's see who is going to tell me first. Yes. So I'm not going to share my screen until and unless you have completed this thing. School 1, school 2, both be very quick. Let's see who is going to give me the answer first. Once done, please let me know, okay? So just write the steps. We don't need to write all the process, just the steps, right? Okay. Let's see. Anyone who has done? Anyone? Yes. Middle, first row, middle bench. Are you not writing? Try it once. Okay, written.
Sir.
That's great. Okay. So if you have written, just help us. School 2, anyone who wants to? Okay, this too you have written between the video when I was playing the video, right? Yes or no? Okay, no issues. No issues. Okay. So yes, first of all, what we have to do? Okay. Take a paper. Yes, take a paper, draw a line.
4 centimeters.
Draw a line 4 centimeter away from the tip of paper, right?
Sir.
Draw a line 4 centimeter away from tip. Okay, next. Next. Okay. Next, what we have to do? We have to make a horizontal line as well, right?
Sir.
Yes. Draw a horizontal line. Draw a horizontal line passing through the vertical line. Okay.
Sir.
And then what we have to do? At point P, right? At point P, we have to do what? Yes, and at point P, put the ink and dip the paper into water. Yes or no?
Sir.
Dip the paper into water, and along with the water, which thing we had? Isopropyl, right? Water plus isopropyl. And then after some time, what is going to happen? Yes, after some time, the colors, yes, or we can say the components of black ink will be what? Will be separated. Yes or no?
Yes, sir.
That's great. How many of you understood this particular process of separation? Okay, that's great. Get back to your seat. Clap for him. What's your name?
Kamaluddin, sir.
Okay, that's very good. Clap for him, everyone. That's great. Everyone understood this process? Any doubts in this?
No, sir.
Anyone?
No, sir.
Okay, that's great. Now let's move. Do you want this to write? Should I give you time to write this? Written? How many of you have written? Okay, so you are very quick, super fast. School 2 done?
Yes, sir.
Okay, that's great. That's great. So if done, should we move to the next process, school 1 and school 2?
Yes, sir.
That's it. School 1, I'm unable to hear you. Yes or no?
Yes, sir.
That's great. That's the spirit. Okay, now let's move with the another process, which is known as distillation. This process is known as what? And which kind of liquid is used to separate the which kind of liquid does it involve the separation? It involves the separation of, means, is it dissolvable or not? Yes. So the example of this kind of mixture is the acetone and water. Yes or no?
Yes, sir.
Okay. So ready for the video, everyone?
Yes, sir.
That's very good. So give me 1 second. I'm going to have the video again. So let's see. Let's have that video again. That is the distillation. Ready? Now, see, distillation is basically of two types. One is the simple distillation and the other one is the fractional distillation. So if in question it just says distillation, you have to know what that the question is talking about, the simple distillation. Yes or no? And if it question it specify the fractional distillation, then we are going to talk about the fractional distillation. So unless and until it is not specified, we are going to consider distillation as simple distillation only. Clear? Don't talk. Why both of boys, why you are talking? Yes. Is there any issues? First bencher, school 1. Yes. What? What he is doing? Writing. Okay. Have you missed something?
Yes, sir.
Okay. After this video, I'm going to show you the screen. Okay. Don't worry. Okay. Whatever happens, if you have missed something, tell me. Okay. I'm going to show you the screen again. Okay. Clear? Okay, that's great. Ready to watch the video?
Yes, sir.
That's great. So again, let's have this video.
Our topic for today.
So we have what we are going to discuss is simple distillation, right? Okay. Now see. So what this boy has done, I'm going to tell you the story. He has what? He has spilled the nail polish. Now, do you know nail polish?
Yes, sir.
Okay. So now this nail polish is what? Basically the acetone, right? So we are going to do what? We are going to separate that nail polish. So let's have this particular process. Okay, ready everyone? That's great. So what we are going to do, we are going to take a mixture of the acetone and which kind of water? The distilled water we can take or the simple water we can take. Okay. So this is the flask. And in this flask, now what we are going to do is that we are just going to name this. And this is what this is known as a distillation flask. Okay. And this everyone know what is this? Thermometer. Now why we have used this thermometer? Just because to take care of the temperature. Yes or no?
Yes,
Okay. Now what we are going to do, we are going to connect what? Connect this particular thing, which is known as the water condenser, okay, to this particular flask, right? Now, what is the use of this water condenser? This is going to cool down the whatever the we are going to get the mixture. This water condenser is going to cool that mixture, okay? Yes, and that water condenser is attached to this particular beaker. Yes or no?
Yes, sir.
Now let's see what this boy is going to do. He is going to heat this particular mixture. Yes or no? Now, after heating, what is going to happen? See the thermometer. What is going to happen? The temperature is going to rise. Yes or no?
Yes, sir.
Okay. Now, since we need to what? We have the mixture of water and the acetone, right? And the boiling point of the acetone is basically 56 degrees Celsius. So what is going to happen? At 56 degrees Celsius, the acetone is going to evaporate. Yes or no?
Yes, sir.
And then that gas is going to pass through this water condenser, and here water condenser is going to cool that gas, and we are going to get the acetone in the liquid form. Yes or no?
Yes,
Understood everyone what we have done?
sir.
Or should I explain it once again?
Yes,
Understood?
sir. No, sir.
Not understood? Okay, okay, no issues. I am going to make you understand once again. Okay, have you seen the video? Is there any doubt in the video? Video is clear to everyone?
Yes, sir.
Okay, that's great. What I'm going to do is that I'm going to explain you this I'm going to write and I'm going to explain for you. Ready, everyone?
Yes,
Okay,
sir.
how many of you understood this? Anyone who understood this? Okay, no one understood. Okay, how many of you understood like 50%? How many of you understood 50%? Okay, that's great. How many of you didn't understood at all? Okay, no issues, no issues. If you didn't understood at all, that's okay. We are going to discuss it right away. Now see. So let's get back to the distillation process. So here, what things we are having, see. Are you able to see this particular thing? Yes or no?
Yes, sir.
Okay. So this is known as what? This was known as a distillation flask. Yes or no?
Yes, sir.
Let's write here distillation flask, right? Now, after this, what is going to happen? We are going in this distillation flask, we are taking acetone as well as what? Water. Yes or no?
Sir.
It is a mixture of acetone and water, right? And from this mixture, what things we have to separate? We have to separate acetone. Yes or no? Now, what is the boiling point of acetone? 56 degree, right? Now that means what? As soon as the temperature is going to reach to 56 degree, water will remain as such, but the acetone will start vaporizing. Yes or no?
Sir.
So whatever the vapors we have here, these vapors are having what? Is it acetone or something else? Is it just the acetone or just the water vapor? Acetone, exactly. Now this vapor of acetone is going to travel here, yes or no?
Yes, sir.
From here, will it enter in this tube?
Yes, sir.
Now see, this is the condenser. Now the work of the condenser is what? To lower the temperature. What is the work?
Lower the temperature.
Lower the temperature. Now let's suppose this particular condenser lowered the temperature to around 50 degrees Celsius. So what is going to happen? The acetone which was in vapor form, it will again come into liquid form.
Yes, sir.
And then whatever you are going to get in this particular beaker, is it a pure acetone? Yes or no?
Yes, sir.
Now understood everyone?
Yes, sir.
Any doubts?
No, sir.
Okay. So I'm going to name the steps. So first of all, what you have to do is that you have to, okay, this one is first, then we are going to heat it second, right? Then the vapor is going to form third, then the vapor is going to come into this tube, that is fourth step, and finally you are going to get the pure acetone. Yes or no?
Yes, sir.
Any doubts still here?
No, sir.
That's great. So do you want to write this?
Yes, sir.
Okay, I'm going to give you how much time you're going to take? 1 minute? Okay, that's great. That's very good. So if you want to just draw the diagram, so what you can do is that a very rough diagram can be drawn, right? Draw it like this, draw the flask and draw this particular condenser and just draw this particular beaker, okay? And name it properly. Afterwards, what you can do is that you can just draw this particular diagram in your notebook beautifully, okay? Today I'm going to give you a homework. Are you going to do that homework?
Yes, sir.
Okay, before ending the class, just remind me that I have to give you a homework, okay?
Sir.
Okay, that's good. Written everyone?
Yes,
Is
sir.
someone asking something? Any doubts?
No, sir.
Okay, that's great. Should I move forward?
Yes, sir.
Okay, I can hear both no and yes, sir. What should I do?
No, sir.
No? Okay, that's great. So I'm going to wait for you all. Done, done, done? No? Yes? Everyone done?
Yes, sir.
Okay, that's it. School 2 done? That's great. So should I move forward?
Yes, sir.
Okay. Again, if you're going to tell me no, sir, but still I'm going to move forward. Okay. So the process we have written here only, yes or no? So for your reference, I'm just going to write here C in the diagram. Yes or no? That's great. Now, let's move forward and let's have another method which is known as fractional distillation method. What is this? Yes. So this is a kind, like everything will be same as the distillation, but there will be some difference. And this is what this is used to separate, what this is used to separate the liquids which are having what, which are having their boiling point difference as 25 degrees Celsius. Okay. Yes or no? Like let's suppose that there is liquid X. Let us suppose that there is liquid X and there is liquid Y. Okay. What is this? There is liquid X and there is liquid Y. And what will be the difference between the boiling point? It should be what? The difference between the boiling point should be less than 25 degree. Okay. And for this case, what we are going to use? We are going to use this fractional distillation method. Yes or no?
Yes, sir.
Clear to everyone?
Yes,
So
sir.
distillation process can be used for any kind of liquids, right? But fractional distillation can be used for only those kind of liquids which are having their boiling point difference as less than 25 degrees Celsius. Clear?
Yes, sir.
Should I show you the video now?
Yes, sir.
Okay. So again, you know that drill, right? We have to see the video and then what we are going to do? We're going to write the process. Clear?
Yes, sir.
Okay. So let's see this particular video and let's have what they are going to do with this. See, now we are going to have acetone and benzene. This is a particular solution. Okay. Now see, if I talk about this thing, what is going to happen? What mixture we are taking? We are taking the acetone and benzene. Yes or no?
Yes, sir.
Now see, if I am going to talk about their boiling point, so the difference between the boiling point is just the 24 Kelvin, okay? Or we can say what the difference between the boiling point of these particular liquids is just what 24 degrees Celsius. Yes or no?
Yes, sir.
Now the setup here we are going to use is this kind of setup, right? Are you able to see this? So instead of a one tube, we are having what? We are having multiple chambers. Yes or no?
Yes, sir.
Now see, what is going to happen? This particular thing is known as fractionating column, then distillation flask, then the water condenser, and then we are going to have what the beaker and all those things, right? Now, the whole setup is what they are put into the water, and then we are going to heat this. Okay, so now understood the particular thing, like how this thing is done. The setup is understood or not? Yes or no? Setup. I am not talking about the process. The setup, did you understood or not? Process, I am going to tell you. Setup understood? No? Okay, no issues. How many of you didn't understood the setup? Raise your hands. Okay. Okay, only this much didn't understood. That's great. Okay. And how many understood 80% setup? Just the setup, not talking about the process. We didn't discuss the process, right? How many of you understood the setup? Okay, that's great. Okay. Now see, again, what we are going to do is that we are going to understood this thing with this particular diagram. Okay. Now see, here can you see these things? Yes or no? Is this visible to everyone? Right? So I'm going to draw this diagram for you. Let's have what? Let's have this particular thing. So here we have what? A beaker. Yes or no? Do we have a beaker in this? And in this beaker, what we are going to have? We are going to have what? The mixture of acetone and benzene. Yes or no? Let's have acetone and benzene. Clear? And here what we have to know is that the difference between the boiling point of acetone and benzene is more than 25 or 24 degrees Celsius, or less than 24 or 25 degrees Celsius.
Less than 25 degrees.
Yes. Now see, after this, what we are going to have? We are going to have this kind of setup, right? So let's have what? Let's close this. Let's close this and join this particular thing with what? With the fractional distillation column. Okay.
Sir.
Yes or no?
Yes, sir.
Yes, that's great. Now, after this, this particular fractional distillation column will be having thermometer. Yes or no?
Yes, sir.
Right? Why thermometer?
To check the temperature.
Exactly. Yes, that's great. Now, see, this again, what they're going to do, this all the things will be what? They will be connected with this particular rod, that is the water condenser, to a particular flask. Yes or no? So let's do that.
Yes, sir.
Okay. So this, let's suppose this is the water condenser, and then this is what? This is connected with a flask. Yes or no?
Yes, sir.
Let's make the flask again. Clear?
Sir.
Now, are we going to heat this? Obviously, are we going to heat this?
Yes, sir.
Yes. So now see, let's provide the heat. So what is going to happen? As soon as we are going to reach the 56 degrees Celsius, what is going to happen? The vapors of this acetone is going to come and it is going to be collected in this flask. Yes or no?
Yes, sir.
Now see, if suppose that I'm going to add some other things, let's suppose any other particular, let's add water also. Let's add what? Water also, right? Now see, what is going to happen? Unless and until I'm not going to increase the temperature till 100 degrees Celsius, will water be separated? Think about it. No, right? So see, first of all, what we did in fractional distillation, we separated the acetone, okay, and we got the acetone. Then if suppose I want to separate the water also, then what I'm going to do is that in the same method, in the same setup, I'm just going to increase the temperature, and then I'm going to replace this flask with a very new flask, and in that we are going to get water when I'm going to increase the temperature to 100 degrees Celsius. Yes or no?
Yes, sir.
Right? So this process is same as the distillation, but the major thing here, we are involving what? This fractional distillation column. Yes or no?
Yes, sir.
And if we are going to if we know the process of, if we know the difference between the boiling point, we can easily use this process for which kind of solution? The solution which is having the boiling point less than 25 degrees Celsius. Yes or no?
Sir.
That's it. Now understood, everyone?
Yes, sir.
Anyone who still didn't understand, please let me know. I'm going to explain you again. Is there anyone? No one? Okay, that's great. So now, should we move forward?
Yes, sir.
Okay. Now, this is a process in which we are going to separate the components of air. Okay. Now, we all know that air is a mixture of gases. Yes or no? Okay. Yes or no? Do you know that air is a mixture of gases? Lots and lots of gases are present. Yes or no?
Yes, sir.
Okay. Now, if suppose we want to separate those gases, then what we need to do? Yes?
Please show fraction of deflation, sir.
Okay, sure. Take this.
No diagram, sir.
This diagram, is it visible?
Topic, sir.
Okay, you are making the diagram?
Definition, sir.
Yes?
Definition, sir.
Okay, definition. Okay, yes. Okay. Once done, let me know, okay? What happened? Who shouted like this? Was it from school 1 or school 2?
School 2, sir.
School 2, okay. School 2 understood the fractional distillation method? Yes? What? I have not got the bi-weekly test results today. I have not got the bi-weekly test results today. Once I'm going to check the bi-weekly test results, then only I'm going to show you. You remember the deal, right? If you're going to have a good marks in bi-weekly, then only I'm going to show. Remember that deal? Okay. Done, everyone?
Yes, sir.
Okay, so you have the upcoming bi-weekly again this week, yes or no?
Yes, sir.
Okay, so revise these portions, and the questions of these bi-weekly is kind of hard. I'm going to set the bi-weekly question hard. Should I do that?
Yes, sir.
Yes?
Yes, sir.
Okay, so the questions will be at that kind of level which everyone can attempt and which everyone can get the high marks if you are going to revise it properly, right? Okay, so school 2, did you watch the previous lecture video? School 2, did you watch the previous lecture video? Yes, watched? Okay, so you know the drill, right? I told in the previous video that you are going, if everyone is going to get full marks, or let's have the average. Let's take the average as more than 90%. Then I'm going to show you my dog, okay?
Yes, sir.
Yes, let's have an average 90%. But below 90%, if it's 89.5 also, I'm not going to show.
Yes, sir.
Okay, done?
Yes, sir.
Okay, that's great. Now, we have done with the fractional distillation method. Any doubts in this?
No, sir.
That's great. Let's now move on to the separation of the components of air. Now, let's suppose if we want to separate these components, then what we can do. Okay, I'm going to again share my screen, and we are going to see this video. Now see. So this is what, this is the chamber in which we are going to, yes, everyone, why I can't hear, why I am hearing the noise from you all? Okay. School 1, school 2, please maintain the silence. Okay, now let's start this. Let us start this. So here what we are going to do. See, there is a chamber in which the air is going to enter. Okay, then we are going to close that chamber once the air has been entered. Now, what is going to happen? We are going to compress the air. Okay, so that the air can be what? The air can be converted into the liquid. Yes or no?
Yes, sir.
Remember, no, when we are increasing the pressure, the air, the gases can be converted into liquid. Yes. So in this chamber, we have compressed the air. Now what we are going to do, we're just going to transfer that air into this temperature. Okay. And we are going to cool it down. Okay. What we're going to do, we are going to cool this. The temperature is going to do what? The temperature is going to become decreased. And then see how we are cooling it, understood, in this particular chamber. Again, what is going to happen now? From here we are going to see this one. Just give me 1 second. I am going to share my screen again. Understood? This much understood, yes or no? Yes, sir. Okay. So after that, see what we are going to do. Okay. Now, is my screen visible? Okay. Now I think so. Is my screen visible? Yes. Now say yes. Is it visible? Okay, that's great. Now, till here we have done, right? This was the chamber, air chamber, yes or no? Here we have cooled this, yes or no? Yes. Now see what is going to, this is the chamber where we are going to what? We are going to separate all the gases. See, if we talk about the carbon dioxide gas, right? So when you cool the carbon dioxide gas, it gets converted into solid form. So when you have cooled that, so carbon dioxide can be easily separated from this particular mixture, yes or no? Why? Because it has become solid. Yes. So in the air, once what we have cooled the air, and when we have decreased the temperature, so in the mixture of air, the carbon dioxide gas gets converted into solid form, right? So can you just separate the solid particle from the liquid one very easily? Yes or no? Yes, sir. Now, the remaining particles are then moved, and we do what? We do the method which is known as fractional distillation. So we are going to check the boiling point of nitrogen and argon, nitrogen and oxygen. So they have what? They have different boiling points, and their difference in boiling points is less than 24 degrees Celsius. So we are going to use fractional distillation method to separate all the other components. Yes or no? Yes, sir. Clear to everyone? Yes, sir. Any doubts? No, sir. Okay, so should I name these steps? This is the step 1, in which we have to enter the air. Then we have to what? Compress the air, right? And then we have to cool down the air. And then what we can do? Then we can separate the solid carbon dioxide. And finally, with the help of fractional distillation method, we can separate all the components of the air in the liquid form. Yes or no? Clear to everyone? Yes, sir. Unable to hear it properly. Clear to everyone? Yes, that's great. Do you want to note this? Yes, sir. Okay, I'm giving you 2 minutes or 1 minute time to note this down. No? Then how much time you need?
5 minutes, sir.
What? 5 minutes? Completed?
Yes, sir.
Okay, that was very fast. That's great if you have completed. Now, next we have one more process, which is sublimation, and this is very, very easy. Okay, sublimation. Do you remember sublimation? Process of conversion of a solid substance into a gaseous substance, yes or no?
Yes, sir.
There is no liquid state in between. You remember this?
Yes, sir.
Yes. So in this kind of, this sublimation is what they're used to separate heterogeneous mixture. Which kind of mixture? Yes. And the example for this is naphthalene balls and camphor. Okay, now, do you know this naphthalene balls? We use in the washrooms, we use in our cupboards to make like keep the winter dresses fresh, yes or no? And do you know camphor? Yes, everyone? No, camphor you don't know. Kapoor, do you know? That is a camphor only. Now understood? Okay, everyone knows Kapoor, right? That the English name of the Kapoor is the camphor. Now see, if what I do is that I take the naphthalene ball and I take the Kapoor, I'm just going to crush and mix it. Will you be able to figure it out which is camphor and which is naphthalene ball? So then for that, we are going to use this particular method, which is sublimation. What you are going to do, you are just going to keep that Kapoor and camphor mixture here and you're going to heat it. And what is going to happen, the camphor is going to vaporize and you're going to have the vapors of the camphors in this particular area from where you can get the camphor. And below, we are going to have this naphthalene balls. Okay. There is one more example, which is the what? Which is the mixture of ammonium chloride salt. Okay. Yes. So this ammonium chloride salt can also be heated up. And when we are going to heat it, it contains some of the what? It contains some of the sodium molecules as well. So the sodium molecules, sodium chloride will be what? It will be separated here. And you can just take out the sodium chloride and the ammonium chloride will be present here only, right? So this is how we can separate the heterogeneous mixture with the help of process which is known as sublimation. Yes or no? Understood or not? How many of you understood this? Okay. How many of you want me to repeat this process? Anyone? No one? Okay, that's great. So in the next class, what I'm going to do is that I'm going just you need to what you make a flow chart of this particular thing. Okay, the method of separations and just make the flow charts like this. Just for an example, let's see like this. Okay, suppose how many whatever the methods we have discussed, you're going to write these methods like this. Let's suppose sublimation, evaporation, fractional distillation, and what else we have discussed? Yes, sublimation, evaporation, fractional distillation, the normal distillation. Yes, you're going to make this kind of flow chart and you are going to write the basic terms, main terms, and in the next class of PS, you are going to show me how many of you are going to do this. How many of you are going to do this homework? Okay, so let's see. I'm going to check it. Okay, who is going to remind me for the homework? That sir, you have given the homework in case I forgotten. Okay, everyone is going to remind me.
Yes, sir.
Okay, and that's great. So let me give the responsibility to in school one. Let's have Sumer. Sumer is present.
Yes, sir.
Okay, so for the school one, let's give the responsibility to the first boy who is sitting in the first row. You're going to remind me, okay?
Okay, sir.
Okay. And in the school two, let's have Akhil. Is Akhil present? No. Is Siddhartha present? Akhil is present? Okay. So you are going to remind me for the homework to check the homework in the next class, okay? Okay. Okay, everyone. Is there any doubts, any kind of doubts to anyone? We have completed this chapter successfully, yes or no? All the points in this chapter has been discussed, right? So what you have to do, just go to your home, open your textbook, revise these chapters, revise the lines, and in case you are having any doubts, we will be having a revision session for this chapter, right? And in that case, you are going to ask all the doubts in that class. Yes or no? That's it. Revise it properly and prepare for the bi-weekly. All the very best to everyone. Till then, bye-bye everyone.
Hey, teacher,